Mars has fascinated humanity since the dawn of civilization. Ancient cultures saw it as a fiery wanderer in the heavens, naming it after gods of war because of its blood-red glow. For centuries, it remained a distant mystery, a wandering light in the night sky that sparked imagination and speculation. Today, thanks to decades of spacecraft exploration, we know Mars is far more than a red dot. It is a world of astonishing wonders, filled with towering mountains, endless canyons, frozen water reserves, violent storms, strange sunsets, and clues to a past that may once have supported life. Every mission sent to Mars has peeled back another layer of its secrets, revealing a planet both alien and strangely familiar. One of the most breathtaking wonders of Mars is Olympus Mons, the tallest volcano in the solar system. Rising about 22 kilometers above the Martian plains, it stands nearly 3 times taller than Mount Everest. Its base stretches so wide that the curvature of the planet hides its summit from anyone standing below. This colossal volcano formed from countless lava flows over millions of years, evidence that Mars was once geologically active. Although Olympus Mons is now dormant, its immense presence tells the story of a planet that once pulsed with internal heat, shaping a dramatic and rugged landscape. Not far from this giant lies another marvel, Val Marineris, the largest canyon system known in the solar system. It stretches more than 4,000 kilometers, roughly the width of the United States, and plunges up to 7 kilometers deep. From orbit, it looks like a colossal scar carved across the planet's surface. Its steep cliffs expose layers of Martian crust, offering scientists a window into the planet's ancient history. Whether formed by tectonic forces, collapsing ground, or ancient flowing water, Val Marineris remains one of Mars' most spectacular and mysterious features. At the poles of Mars lie vast ice caps made of frozen water and carbon dioxide. These polar regions grow and shrink with the Martian seasons, creating a slow, rhythmic breathing of the planet's climate. Beneath these ice caps, radar scans have detected possible liquid water reservoirs trapped under layers of ice and rock. Elsewhere, spacecraft have found buried ice just beneath the surface in mid-latitude regions. This hidden water is one of Mars' greatest treasures, offering not only clues to its past but hope for future human explorers who may one day use it for drinking water, oxygen production, and fuel. Perhaps the most thrilling discovery about Mars is the overwhelming evidence that liquid water once flowed across its surface. Ancient river channels snake across the landscape, dry lake beds fill impact craters, and delta formations reveal where rivers once emptied into long-lost seas. Minerals discovered by robotic rovers form only in the presence of water, confirming that Mars was once warmer and wetter than it is today. Billions of years ago, Mars may have had rain, flowing rivers, and standing bodies of water. This raises one of the greatest questions in science. If Mars once had water, did it also have life? Even simple microbial life would change our understanding of biology in the universe forever. That possibility drives scientists to search for chemical traces, fossil-like structures, and organic molecules hidden in Martian rocks. Every sample drilled by robotic explorers is a potential time capsule from an ancient world. The Martian atmosphere, though thin, creates a sky of unusual beauty. During the day, the sky appears dusty and pinkish due to fine particles suspended in the air. Mars is also home to immense dust storms, some of which grow so large they cover the entire planet. These storms whip fine dust into the atmosphere, blotting out sunlight for weeks or even months. Spacecraft have watched as these storms engulf the world in a swirling veil, reshaping the surface and altering atmospheric conditions. For robotic explorers, such storms are dangerous, sometimes cutting off solar power and communication. Yet they are part of Mars' natural rhythm, evidence of a living and changing world. Much of what we know about Mars today was made possible by a legacy of spacecraft exploration that began in the same golden era that launched the Voyager missions. Although the Voyager spacecraft did not visit Mars directly, they revolutionized planetary science. Their discoveries at the outer planets transformed how scientists built and operated interplanetary missions. The technologies, navigation methods, imaging systems, and scientific planning strategies pioneered by Voyager became the foundation for later Mars missions. In many ways, every Mars orbiter and rover carries the scientific DNA of Voyager. Following this legacy, orbiters such as Mars Odyssey and Mars Reconnaissance Orbiter mapped the planet in extraordinary detail. They revealed hidden canyons, underground ice, ancient shorelines, and mineral compositions invisible to the naked eye. Earlier missions like Mariner and Viking performed the first close-up studies of Mars and carried out pioneering experiments searching for life in Martian soil. The Viking landers returned mysterious results that still spark scientific debate today. Later rovers such as Spirit, Opportunity, Curiosity, and Perseverance transformed Mars from a distant object into a place we feel we know. They climbed hills, crossed plains, drilled rocks, and sent back images of landscapes both alien and strangely familiar. Curiosity discovered ancient lake sediments and organic molecules, while Perseverance now explores Jezero Crater, once a lake fed by a river delta. It collects rock samples that may one day be returned to Earth, possibly answering the question of whether life once existed on Mars. Another wonder of Mars lies beneath its rusty soil, evidence that the planet once had a global magnetic field. Another wonder of Mars lies beneath its rusty soil, evidence that the planet once had a global magnetic field. Unlike Earth, Mars does not have a strong magnetic shield today. However, spacecraft have detected patches of magnetized crust, proof that long ago Mars possessed a protective field that guarded its atmosphere from the harsh solar wind. When this magnetic shield faded, the solar wind gradually stripped away much of the planet's atmosphere. Over time, Mars transformed from a warm, water-rich world into the cold and dry desert planet we see today. This discovery not only explains Mars' dramatic change but also teaches scientists valuable lessons about how planets evolve and how fragile habitable environments can be. Even the sounds of Mars have become part of its wonders. Recent missions have recorded audio from the Martian surface, the whisper of wind across rocky plains, the faint rumble of dust devils passing nearby, and the mechanical hum of robotic explorers at work. For the first time in history, humanity has heard the voice of another planet. These recordings make Mars feel less like a distant world and more like a place we might someday stand upon. Every discovery on Mars deepens our connection to it. It is a planet that tells a story of transformation, from a once active world with flowing water and a thicker atmosphere to a silent land of dust and ice. It holds answers to questions about planetary evolution, climate change, and the origins of life. It challenges engineers to design machines that can survive its harsh conditions, excites scientists searching for ancient biosignatures, and inspires dreamers who imagine human footsteps on its soil. One day, astronauts may walk across Martian plains, climb rocky ridges, and gaze up at a small blue Earth hanging in the sky. They may drill beneath the surface to search for life, grow plants in protected habitats, and watch blue sunsets from a world that was once only a point of light in the night. Mars represents humanity's next great frontier, a stepping stone to deeper exploration of the solar system and beyond. Yet even before humans arrive, Mars continues to teach us. It reminds us that planets can change dramatically over time. It shows us that water, atmosphere, and magnetic protection are vital ingredients for life. It warns us how delicate planetary balance can be. And at the same time, it offers hope that worlds beyond Earth may have once supported life, and perhaps still do. The wonders of Mars are not only in its towering volcanoes, endless canyons, hidden ice, and raging storms. They are in the mysteries it holds, the questions it raises, and the future it invites us to pursue. A silent world that once flowed with water, possibly carried life, and now waits patiently for humanity to explore it. Mars is not merely a planet. It is a story still being written.